Hello everyone and welcome back to Chopstick Maths. In this video, we will learn about converting a number from the rectangular form to the polar form. Now express the number z is equal to 1 minus I in the polar form. The number z equals to 1 minus I, it lies in the quadrant 4 because its real part, that is the x, is positive and the imaginary part y is negative. Hence it lies in the quadrant 4. Now let us represent this number on the Argand's diagram. The number z is equal to 1 minus I, where x is equal to 1 and y is equal to minus I. Now, the point P is the location of the complex number 1 minus I. So, now let us find the magnitude of this particular complex number. Now, magnitude of a complex number is the distance of the number from the origin. In short, it is the length of the segment OP. And this can be very easily calculated using Pythagoras, because this is a right angle triangle, this is the magnitude r, this is the x coordinate and this is the y coordinate. So z is equal to x square plus y square, the whole under root. So z is equal to under root x is equal to 1 square plus negative 1 square. So z will be 1 plus 1. So z will be root of 1 plus 1. So z will be equal to root of 2. So that is the magnitude of the number. The magnitude is z is equal to root 2. Now let us calculate the argument, because magnitude and argument are the two things that are necessary for representing a number in the polar form. Now, if you look here, the number is represented on the Argand's diagram. Now here, argument is the angle made by the arm OP with the positive x-axis. Now if you look here, OP is making an angle theta with the positive x-axis and theta is rotating along the anti-clockwise direction. So theta is positive and OP is also making an angle alpha with the positive x-axis, and here OP is rotating along the clockwise direction, so alpha will be negative. So the formula is alpha is tan inverse y by x. Now y is negative 1, x is positive 1. However, we will put positive values, that is alpha is equal to tan inverse 1 by 1. And since we have put positive values, we get alpha is equal to tan inverse 1, that is equal to pi by 4 radians. Now we have got a positive angle because we have put x and y both as positive. However, the arm is turning along the clockwise direction, so this angle is negative. So we will write theta is equal to minus pi by 4. That's the negative value of alpha. That is equal to minus pi by 4. The other value, that is the positive value, can be easily calculated using 2 pi minus alpha. So it will be 2 pi minus pi by 4, that will be equal to 7 pi by 4. So theta has two values. One is negative pi by 4 radian and the other one is 7 pi by 4 radian. Now, we can use any angle, either negative pi by 4 or 7 pi by 4 to represent the number in the polar form. But here we will be using both. So z is equal to r cos theta plus I sin theta is the general expression for representing the number in the polar form. And as we have already calculated the magnitude r and the argument theta. So z is equal to r is root 2 cos, we will first use the angle negative pi by 4, cos minus pi by 4 plus I sine minus pi by 4. Now, in trigonometry, cos of minus theta is cos theta, whereas sine of minus theta is minus sine theta. So, z is equal to root 2 cos of pi by 4, and here this would be minus sine pi by 4, so it becomes minus I sine pi by 4. So, this is the first way of representing the number in the polar form using the angle minus pi by 4. Now, using the angle 7 pi by 4, z is equal to root 2 cos 7 pi by 4 plus I sine 7 pi by 4. This is the second way of expressing the number. So, these are the two ways of expressing the number z is equal to 1 minus I in the polar form. Thank you very much for listening.